Hello everyone, welcome to the Web3 Education Investment. Today in this video, let's talk about the Nomad. Because yesterday I just made a video for the Moonbeam. They have the event, right? And I start to take a look at each of the project, and I find out the Nomad, one of the project, is actually a bridge to Moonbeam, gets hacked. And surprisingly, they actually get hacked for more than 200 million. That's actually a lot, quite a lot. So let's talk about this case in in this video. What happened and what could be influenced, and what can we learn from this incident. And so immediately Moonbeam, they actually post a tweet. It's yesterday, I think, yesterday night. I missed that. And so they said the incident is not going to impact anything to Moonbeam. So that's very fortunate actually for Moonbeam. So everything influences the asset on the Ethereum main chain smart contract. So that's also kind of the thing I talked before, all of those security issue, right? I didn't see many in Polkadot actually, and most of them they happen in Ethereum. And why that's the case? I could imagine one of the issue would be the smart contract. The Nomad is a bridge, and then let's just go to the Nomad, the bridge here. So yesterday I said I probably will demo, right, how to earn those NFT. But I also said should be careful, especially those bridges. The security is always an issue for those bridge. And so for the Nomad, the bridge, what happened is there will be two network. And so normally you can bridge from Moonbeam. Now it will ask me to connect my wallet, okay? And so you will have the Moonbeam to the, for example, you bridge that to Ethereum. And so what happened is you have two blockchain, right? One is a Moonbeam, it's on Polkadot. Another one is Ethereum. And so you want to send the asset from Moonbeam to the Ethereum. The bridge, normally they will have two different smart contracts, like one on Moonbeam, right? You will knock users' asset. And another one on Ethereum, that's another smart contract that will take the message. Actually, there should be a message sending from Polkadot. In this case would be Moonbeam. So sending from Moonbeam to the Ethereum. And so the security issue would happen when the message is not the correct one. So for example, I knock my asset, I send 10 dot, let's say. I send 10 dot from Moonbeam, right, to the Ethereum. So now the Moonbeam, the smart contract will be okay. It will take my 10 dots, and then it will send a message to another blockchain, Ethereum. And the message will say, okay, now the user already knocked his 10 dot. Now I want you to give the user, right, 10 dot on Ethereum. So that will just send the token, right, to the Ethereum. So these two smart contracts, they will communicate. But when they talk to each other, you go through the message, but this message is not it's not something it's not something like in the blockchain, in the same blockchain. It's outside of the blockchain. So the hackers, they could generate a wrong message. So for example, I send a dot, right? I send a dot from Moonbeam to the Ethereum. I send 100 dot, and then it goes through. So everything goes through correctly. Then I will generate one message, right? Generate one message. That message will tell the Ethereum smart contract saying, okay, now you the user just send 100 dot. and please give the user 100 DOT on Ethereum, right? That's the whole process. Then this message now, it will contain my address, right? So in this case, this is my address, for example. And then the hackers, if they change the message, what happened? If they change the message from this address to another address, then the smart contract on Ethereum, they probably will just give it to another people, right? And what's even worse is what happened if the hacker, they generate several message, the same message, actually the same message, they just keep generating the same message again and again. The smart contract on the Ethereum, they have to check whether this is a message, whether that's a valid message, right? And it's kind of difficult for the Ethereum smart contract to check that, because they have to verify this message is coming from this from the Moonbeam and it's valid. It's kind of difficult to check that. So I also take some time and check the smart contract. And so this is a smart contract I have found. And this is written by Solidity. I'm also new, like I'm just trying to learn, try to understand the code, and I would be happy to share my findings. So looks like this one, the replica, looks like that's one like they're going to start from here with all the code, and I do notice they have some initialization. So like here, this initialization, right? They set up some storage variable, remote domain, right? And then there's one thing like maybe that will cause an issue, like they pre-approve the committed root. And so like when they initialize, they approve that. Did that mean like when users, right, they send the message from the Moonbeam to Ethereum, they assume like maybe the hackers find out like, okay, you pre-approve that, you always allow the user to send the message. Maybe the hacker will just change some previous message, change the address and send it to the Ethereum. And since you pre-approve that, it'll always it will always give you the token, right? And so this one like initialization might be the issue. That's just my guess, okay? It's just my guess, and you can also check the function process. It do verify, so you can check that. It do verify some destination and the message, right? It do verify those. I guess the verification will verify whether that's a message sending from the Moonbeam. And if the hacker change that message, then this smart contract will process that. It will think, okay, this is a valid one you send from Moonbeam. But if the hacker change the address only, right, all the other message would be the same. So that might be the issue. To verify those my guess, so I also check and find some of the transactions online. Looks like those transactions, you can see that a lot of them, they are just the same number. Yeah, a lot of them, they are the same number. 100, right? So 100, 100, 100. So that's probably the issue. Like the hackers probably just change the old message, which people, like someone, they withdraw 100 Bitcoin, for example, they change the address to themselves and then keep sending the same message. So that's probably the way up. But again, like it's just my guessing. I would like to share. So that also means those bridge, right? They are quite dangerous, like when you use them. So now all the fund on Ethereum, like all the assets, it's already drained. Like there's no assets there. So I also noticed Nomad they close this bridge now. So that this is one thing, but the other one like I do find out is the powerful of this XCM on Polkadot. So Polkadot they also have the they also have the function like the different parachains. You can send the token. You can also send the message, right? And so when you send the message, it's not like the bridge that the message will go out of your ecosystem. It will just go, like the hackers can just create their own message. But the XCM that format is within Polkadot. So it's just like within the same ecosystem. So it's easier to manage. So that is why like the XCM would be much safer than this kind of the random bridge. So somehow I feel the XM can also do the things just like a bridge. So now you notice different parachains, they send different tokens, right? So from the Arcana, right, to the Moonbeam, to the Pioneer Finance, or all kinds of tokens, like those projects, their tokens, like you can find it like on Arcana, they already need a lot of tokens. And those tokens, like they are coming from different parachain. And how they make it happen is by the XCM. So the Polkadot really they take care of the security. So those parachains, they don't need to worry about those security issues. So they will give it to the Polkadot. And then the parachains will focus on their thing, so they can do whatever their job. And then if they need to get the asset, they can just use XCM. And in the latest talk, I also heard about the Dr. Gavin Wood. He talked about like remote knock the asset. So in the future, like if you can remote knock the asset in the other parachain, that will make it even safer, right? If you want to do something, you send the asset, but it's not just send it there and done. You still have remote control, so that would be even much safer than the current bridge. So this video I think is kind of a not just a demo. It's more like share my thoughts and also about the recent accident from Nomad. I really hope Nomad will go over this difficult time. You know, it's kind of difficult for the whole like ecosystem. And also I noticed a safety issue now like on the Ethereum, right, with all the smart contract and the bridge. But on Polkadot, I also feel very glad about this XM and the powerful of the XM. I talked about that several times in my previous video, so I'm quite excited for that technique and how to make everything safe. Okay, so that's all about today's video. Thanks for watching, and I hope all of you stay safe, and please don't try the Nomad now. So the Moonbeam event, I'm sorry, yesterday I posted that Moonbeam event. So hopefully none of you actually actually listen to my video and try the Nomad. Yeah, again, like I feel so bad. But this is just a thing, like the bridge, those things, right? They are quite dangerous. So always be careful, and that's also a lesson we learned in the Web3 safety, right? So try to stay away from those kind of the dangerous place, or maybe like have different wallet. For example, if you have a wallet that is a hardware wallet, for example, or if you have a wallet just have a little bit fund and interact with different dApps, that would be much safer if you have most of your assets in your wallet that you don't actually touch that much. Okay. All right, so that's all for today's video. Thanks for watching, and I will see you next time. Bye.